Hello everyone, my name is Aish Kumar. Welcome back to my video. So today this is my project distributed rate limiter built using Spring Boot and Redis. So basically what my project does, it restricts how many API requests a user can send within a time period using the token bucket algorithm. If the limit is exceeded, the server returns a HTTP response, which is basically an error which is 429, too many requests are sent. Now in this so the current problem which is being faced at the backend is modern backend application usually requires rate limiting to reduce the number of calls made to the backend. So if a single user or a bot sends too many requests continuously, server performance decreases and API may crash. And also some resources may get exhausted, or let's say a DDoS like situation can happen. To prevent this, I'm building this rate limiter. What it does is it is going to cap the limit of a particular IP address, so that a particular IP address can only make a certain request at a particular point of time. Or let's say for example we take like 5 requests per minute, and it reloads the limit after a minute. So the maximum limit for a user which he can send is basically five calls to the backend only. So the objective is to build a distributed rate limiter using Spring Boot and Redis, and to restrict API usage per client IP, and to configure limit dynamically, to support multiple application instances using Redis, and to implement a token bucket algorithm which we have used in this project. So next I'm going to take you to the tech stack which is being used currently in our project. We have used Java for our core programming language, and we have used Spring Boot for our backend, and Redis for, again, I have said earlier about distributed shared storage. And Docker is running the Redis image, and we don't have to install Redis locally. We can just use Docker and directly run the image of Redis. And we have used Maven for the dependency management, and we have used servlet filter to intercept the incoming HTTP requests and to also respond to a few of them. And we have used collection framework heavily in this. Uh, Along with we are using Postman for the API testing, and HTTP headers just to send the rate limit information to the client. So let's move ahead with our project. So this is the entry point of our code. Uh, so this is the rate limiter application. Here, this is the starting point of our Spring Boot application. So this is where we start. So first, I'm going to let you go to the rate limiting filter. Here we have used a few servlet from the Jakarta package, and which contains basically the HTTP servlet request and response. And here, as you can see, that we have used a few things, such as basically we have created a class called rate limiting filter. This filter is basically, it is going to let us this filter is going to let us see that if we have the particular tokens to access the backend once again, or if we lack the token. If we lack the token, we cannot access the backend. If we have the particular tokens required for the particular backend access, then we can directly access it. We'll be seeing in a few minutes about it. And here next we have here two string, which is client IP and the endpoint, which we will be collecting from the client. We require the client IP to map them to the particular tokens which they can send in a particular minute, and also the endpoint at which they are requesting it. And next we have this a key, which is basically in which we'll be storing it inside our map which we have created, uh, which is basically the client IP, and it's a colon and an endpoint. We'll be storing that like that directly inside our maps, which is basically going to create key value pairs. It will be very easier for us to map the IP address with the particular tokens, which particular token along with the time they have taken. Let's say there's a 1 minute timer for each 5 tokens to get expired, and it will be filled with the updated tokens. uh, so that's what we are doing it. And here we have a get client IP, which is going to basically get the client's IP. Here we can see that request.get header, which is going to get the header part of the request which is being sent. And next we have admin controller. So at the part of admin controller, it is basically to update the mapping part, sorry, update the number of tokens per user. We can see this slash admin endpoint, which also has this slash update limits. So admin can easily update the limits of the tokens per user throughout the backend. And the current limits basically shows the current limit. Let's say a particular user has like 10 tokens per minute which he can request to the backend. So if he tries to do more than that, then we'll be having some error handling for that. We'll not let them use more than 10 requests per minute. And we have another which is test controller, which is going to our general endpoint, which is slash API slash hello, which we'll be using today for our postman as well as the browser test. Next we have uh, rate limiting service. So in this we have imported a single thing which is basically model dot rate limit response, which is basically a small thing which we have imported from the other package of the same project. And here you can see the initial capacity for each user is going to be 5 and 5, and we have used a hash map just to map the string along with the list of long, which is basically the time required for each user. And there's a small thing in Redis that you cannot like Redis does not understand any other data type, so ultimately everything has to be passed into a string format, which you'll be seeing in the further part. And uh, next, as we go on, uh, like here it is going to print in the Spring Boot application. You'll be seeing that if we update the limit of the particular tokens per user, then the updated limit will be shown in the logs, as well as we are going to check here. If we come here, for the every request made, a token is going to be reduced for that particular duration of time, and the time is being calculated over here. So for every so this is in milliseconds. So based on that, for every minute, only 5 requests can be made, which we have earlier declared, which is here. And the refill rate, let's say after a minute, if we the the refill amount can also be altered by the admin panel, or else uh, statically we can keep a number here. So that's the current thing happening. And we have another thing which is rate limiting response. So this is just a basic response, which is basically creating a constructor and doing the dependency injection. Next we have application.properties, where we have written the Redis port, which is 6379, which is being run in the Docker container here, 6379. So that is there. And this is the server port 8080 in which would be running our application. And this is the initial limits which you have given over here. And that's it for the thing. We'll be running this application, and we'll be seeing how we are going to limit a particular IP address. So here, when we run it initially, it's a Spring Boot application. We have used so it's a inbuilt. We get a inbuilt Tomcat server along with it. We don't have to configure it manually. Spring Boot does it for us. And here, a small thing which we have used is token bucket rate limiter. I'm going to show you here in the service part if we get into. So here we have used a small thing which is called a token bucket algorithm. So what this token bucket rate limiter does is basically it's a diagram to represent it. So if a user uh, tries to access the backend, so there be a token basis. Let's say there's a bucket and there's a few tokens in it. If a user tries to take a token, so that token will be reduced from the list for a particular duration of time. So as soon as he keeps on requesting the backend, as you can see, which they are shown as try acquire. So if the user continuously does that for 5 times, and 6th time when he tries to again access the backend, he cannot access the backend because he has no tokens to further make requests to it. So as you can see, check if tokens are available. If the tokens are available, then you return the true or false. And again, if the user tries to acquire the backend and he does not have any more tokens, then as you can see, it is going to return false. And that is the same token bucket rate limiter algorithm we have used in our program. Uh, so next, let's just run this for now. We'll make a request over here, which is hello, request is allowed. So this is the same thing which is being made. Um, if we come to the test controller, here you can see that at the endpoint of slash API slash hello, we are getting this hello request is allowed. So currently it is being allowed because we have the token capacity. So we have made already two requests. So this is the third, fourth, and the fifth. And if we again try to do the same thing, we are going to get an error which is too many requests. Please try again. Now the same thing. Uh, it is going to get updated every 60 seconds, so that again the user can make a request to the backend. The same thing we can see it via the backend. Sorry, same thing we can see it through the postman. Here you can see that the request is being made. If we try to send the request, it is allowing us to send currently. So 4 and a fifth. So again, if you try to do the sixth request, it is showing that okay, it's a 429. There are too many requests are being made. So if you get down to the same header part, here currently you can see the current IP address, which is my IPv6 address. IPv6 IP address is being shown over here, and the limit. So the current limit is 5, and the current limit which we are remaining, because we have already made 5 requests, so we do not have more requests until a particular minute has passed. So this is the length of what is being displayed at the back end, and these are just the some raw data around here. So if we get to the body, and I assume that a minute has been made, so we're going to try to send a request again, but the minute has not yet been passed. So what an admin can do, let's say the traffic at the backend increases, admin can have this panel, which is basically endpoint of slash admin slash update limits, which is a capacity of 15 and the refill rate of 15, which you can again configure over here. We'll start with the 10. We'll try to, and this is the post method which we are using, as you can see in the code also. We'll go to the admin controller. Here you can see this is a post mapping, and if we try to do the same thing through the browser, you can see we get to the same thing. And if we try to do it via the browser, you cannot do anything from the browser. The browser only can do as long as, I mean, as great as like a get request, not a post request. That's why we are using postman for this thing, for the API testing part. So here we can just update the limit, which we have not yet done. We can update the limit from here. So the new refill rate is 10, new capacity is 10. If you refresh it, the capacity has been turned to 10. We'll go here, we'll refresh the page. That's the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th. Our 10th request have been made. The 11th request is going to be an error again. So this rate limiting thing is really good, and it's working correctly as intended by our logic which we have written. And you can also increase the limit as long as 15, 20, 100,000. We can keep on increasing the limit as long as we need it. So again we refresh it. So every time the post method updates the limit, the all the bucket which is being holding the tokens, it gets refreshed. Now one request have been made, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 requests have been made, and 16th request is going to be an error. So we are going to open the thing over here. So you can check the Spring Boot log over here. This is basically the rate limit updated to 10, which we have made earlier, and again we made 10 requests. After that we updated the limit to 15, which is being made successfully. After that we made the 15 request, and it is being stopped because the limit has been reached. So that's how our small application is implementing rate limiting very efficiently, and it gives our desired output, uh, which is to stop the client from giving many requests to the backend. So that's it for the video. I hope you like the video. Thank you.